Dear students, welcome to Physics World. Today we shall study refraction through lens, the numericals based on lens formula. So, in this we are the previous knowledge which should be there is that the lens formula is 1 by f, that is equal to 1 by v minus 1 by u. Magnification m is equal to I by o, that is equal to v by u. Let us quickly see what all these symbols stand for. U stands for the object distance, v stands for the image distance, f stands for focal length, m stands for magnification, I for the image size, o for the object size. Now, let us see how we understand the sign convention of lenses. So, if this is the lens, we have taken or shown over here the convex lens. However, the sign convention does not change for the concave lens also. The optical center of the lens is taken as the origin. Then the principal axis. So, anything left to the optical center is taken as negative, and any length that is right side to the optical center is taken as positive. Anything above the principal axis, that is positive, and any length below the principal axis, that is taken as negative. So, let us see how the sign convention becomes for two different lenses, the convex lens as well as the concave lens. First, let us talk about the u, that is the object distance. Object distance is always negative, and that is so for both the convex lens as well as the concave lens, because the object distance is measured to the left hand side from the optical center. So, it becomes negative. Then is the focal length. The focal length is positive for the convex lens and negative for the concave lens. Let us see what about v, that is the image distance. The image distance is positive for the real image, because the real image is formed on the right hand side or behind the lens. Similarly, it is negative for the virtual image, because it is formed in front of the lens. So, v is always negative for the concave lens, whereas for a convex lens it can be positive or negative depending upon whether it is a real image or virtual image respectively. Next, we come to the magnification. The magnification is negative for a real image and positive for virtual image, whereas the magnification is always positive for concave lens, because it is always less than 1 for the concave lens. It is always magnification for a concave lens is always positive, because it is always above the principal axis, because it is always virtual and erect image formed. And since it is always smaller than that of the object, the image size, therefore, the magnification is always less than 1, whereas the magnification for a convex lens can be equal to 1 or greater than 1 or even less than 1 depending upon the situation for the convex lens. Now, the O is always positive for both concave lens as well as the convex lens. Now, coming to I is negative for real and real image, and I is always positive for virtual image. So, therefore, concave lens I is always positive. I can be positive as well as negative depending upon the situation. That means, whether it is a virtual image or it is a real image. Now, dear students, we shall do certain numericals to illustrate the sign convention. There are many numericals given in your book. This is your first part of the lens formula. So, we will do a few of them. So, the first question is, at what position a candle of length 3 centimeter be placed in front of a convex lens so that its image of length 6 centimeter is obtained on a screen placed at a distance 30 centimeter behind the lens. So, you have to find at what position a candle of length 3 centimeter should be placed in front of a convex lens, and also you have to find out what is the focal length of the lens in part A. So, let us see what are the things that are given to us. It has been given that O is 3 centimeter. Now, if O is 3 centimeter, that is the object size, it is always positive according to the sign convention. So, dear students, write then and there over here that it is plus 3 centimeter. Then we are coming to the next part, that is I. I is given as minus 6 centimeter. Now, how do we know that it is minus 6 centimeter? It is formed on a screen, and therefore, it is a real and inverted image, and therefore, it is minus 6 centimeter. Now, over here we have to find out U. V is plus 30 centimeter, that is also given to us. So, let us see magnification, that is I by O, and that is equal to V by U. So, substituting the values that are given to us, I is given as minus 6, O is given as 3 centimeter, that is equal to V is given as 30 centimeter, U is unknown. So, cross multiplying we can get the value of U, and it comes out to be minus 15 centimeter. Minus sign indicates that the object is in front of the lens. So, we write 15 centimeter in front of the candle. Next part, we have to also find out the focal length. Using the formula 1 by f is equal to 1 by v minus 1 by u. Now, dear students, here one mistake the children make is, they over here only, in this part only, they say that u is negative. So, I will just make it minus u. So, it becomes 1 by v plus 1 by u. So, if you are writing 1 by f is equal to 1 by v plus 1 by u, because you have already substituted u is negative, so you will get that. So, in that case, though your answer will come correct, but your answer will not be counted. Why? Because that will become the mirror formula. You have to use the 1 by f is equal to 1 by v minus 1 by u, which is the lens formula. After writing that, you are supposed to substitute with the correct sign and then get the answer. So, do not change the formula over here. After writing the formula, substitute the values. So, 1 by f is equal to 1 by 30. Why? Because v is given as 30 centimeter over here. So, we have substituted minus 1 by minus 15. We have just now got the value of u. So, we substitute that value. Now, we do the calculation and we get the value of f as 10 centimeter, which is correct. This comes as positive. So, it is in accordance because we are calculating for a convex lens. This is numerical number 3, dear students. So, let us see. The focal length of a convex lens is 25 centimeter. At what distance from the optical center of the lens of an object be placed to obtain a virtual image of twice the size? Things which are very important to us. Generally, these are the things which are to be noted. This is a convex lens, and secondly, the magnification is given as 2, the virtual image, and another thing is virtual image. Virtual image shows that the magnification will be plus 2. So, let us see what are the things that are given to us. Focal length is given as plus 25 centimeter. Why plus 25? Because it is a convex lens, so it is plus 25 centimeter. I is given as plus 2x. Why it is given as plus 2x? Because it is a virtual image. O is plus x. Again, O, the size of the object is always above the principal axis, so it is plus. I is plus because it is a virtual image, so again it is above the principal axis. So, the magnification is plus 2. So, we have magnification which is equal to V by U. So, we get 2 is equal to V by U. Now, we have to find out we have to actually find out the object distance. To find out the object's distance, the focal length is known to us, magnification is known to us. So, what we can do is express V in terms of U, so that there is only one unknown left to us. So, 1 by f is equal to 1 by V minus 1 by U. Substitute the values. V, instead of V, we will be substituting 2U. So, we substitute over here and we get the value of U as minus 12.5 centimeter. We need to write that negative sign indicates it is in front of the lens, that is the object indicates the object is in front of the lens. Dear students, this is question number 5. An illuminated object lies at a distance 1 meter from a screen. A convex lens is used to form the image of object on a screen placed at a distance 75 centimeter from the lens. Find the focal length of the lens and the magnification. Now, the solution is that first of all, let us see what is given to us. U plus V is given to us first. Okay. The value of the object distance plus the image distance is given as 1 meter. Here this 1 meter, that is U plus V. Then the V is given as 75 centimeter. Then the U becomes minus 25 centimeter. We have written minus because it is, we know that U is always minus. It is on the left hand side of the lens or in front of the lens. So, it is minus 25 centimeter. So, what we have to find out is the focal length of the lens and the magnification. U is known, V is known, so we can definitely find out the value of f using the lens formula. Again, dear students, we are first going to write down the lens formula. We could have easily written 1 by f is equal to 1 by V minus 1 by U, and thereby instead of writing U, we could have written minus U, so it becomes plus U. No, but we are not going to do like that. We are going to directly substitute the values with the signs. So, we have substituted the values with the signs which we have written already over here. So, it becomes 1 by f is equal to 1 plus 3 by 75, that is 4 by 75. So, f is equal to 75 by 4, that is 18.75, that is the answer. And magnification, they have also asked for magnification. Now, over here it is coming plus, which is in accordance because over here we are using a convex lens. Next is the magnification, which is V by U. V being known to us, U being known to us, let us substitute the values and we get minus 3. Magnification minus 3, so you can write over here negative sign indicates real and inverted image. Dear students, that will all be for today. Do not forget to like, comment, share and subscribe. Also, do not forget to press the bell icon. That way you will get the notification whenever my videos are out. To see more of such videos, please comment and also let me know which are the numericals which you would like to see in my second video. Thank you.